The third source of pressure is through the interaction of molecules. Mathematically, we describe this by the ideal gas law. So consider that you have a container of gas. And when I say a container, that means that it has a certain volume, V. Um, if you add gas, the pressure increases. And when I say add gas, that I increase the amount of gas, which is I'm going to use N to represent the number of gas molecules, and the pressure, I'll use P as we've been doing to represent that. So if I have a set volume of gas and I add additional gas to that container, then that raises the pressure. Because if you imagine, I have this container, if I only have 4 particles in there, and then I double it, then that's going to increase the amount of pressure because those molecules are going to be interacting more. And when they interact more, they move around faster, they bump against the sides of the container, and that increases the pressure of that gas. Also, if you raise the temperature, if you raise the temperature, well, I have this container with gas. If I raise the temperature, these particles will move around faster, and so they'll run into the sides of the container faster, and if that causes the pressure to increase. All right, so we this relationship is called the ideal gas law. It looks like this: PV is equal to N times R times T. Don't worry about the R, that's just a constant. But these other things we've seen, this is our pressure. This is always measured in pascals. That's the SI unit. This is volume. That's in cubic meters. This is the amount of gas. Usually this is either a number of moles or number of molecules. Actually, it doesn't really matter for us because we're just really looking at the relationship. That is that P is proportional to T and P is inversely proportional to V. That second one is called Boyle's law. Boyle's law is a special case where if N and T are constant, that is the amount of gas and the temperature of the gas. If that's true, then PV is equal also to a constant. This should be a capital V. The pressure times the volume is also equal to a constant value. So if this value doesn't change and this value doesn't change, then we're just saying that this value also does not change. Um, and so what this says is that P times V cannot change, so that if the volume goes up, that means that the pressure goes down. Or if the volume goes down, the pressure goes up. Or vice versa. If you change the pressure, then that'll change the volume. A good example of this is when you're breathing. So when you're breathing, you have your lungs. And when you breathe, what you do is you change the volume of your chest cavity. And so when you're breathing in, when you're inhaling, the volume of your chest cavity is going up. That means that the pressure inside of your chest cavity is going to go down, and then high pressure air, which is outside of your body, will rush into your lungs and fill this space with air. Now, when you're exhaling or breathing out, you exhale, your chest cavity gets smaller, and then the pressure goes up. That forces this air out of your lungs and out into the surrounding area. So that's a great application of Boyle's law when you breathe. And we'll see a video, I'll show you a video of the iron lung, which also operates by a similar principle. And I'll also show you an example of this pressure is proportional to the temperature. That is, if the temperature goes up, the pressure goes up. Lots of cool stuff with the ideal gas law.